How are you guys liking working on the team so far? Like the team setup?
Yeah.
Okay, good. Figured it was better than putting you each on this individually, which would have been a little bit of a nightmare. I just want to say, this is stuff, this is area detection is actually one of the most complex things that we're going to do this summer. So it's the first thing I figured, I'm like, put the hardest thing out there first. And we'll have some more difficult variations of what you're doing. Next week we'll start on some curved text, and we'll probably just adapt our algorithms to work with that. I came up with some ideas to make it a little bit easier. But it's actually one of the most difficult things to do. The second most difficult, or equally most difficult, is glyph detection, but we're going to use other people's libraries to do that. We just need to figure out how they work. So it's a different type of challenge. This stuff, there's no libraries out there that do this. There are libraries that do, like, they might match objects, but we are specifically trying to catch text and what it looks like. So we have to do it ourselves. So it's not easy, but both teams are making really good progress. You actually both surprised me, I think last Friday, when you already had some working code. I was not expecting that. So both teams, you guys are doing really well. I'm proud of you guys for doing this. And I want to show you, just to make sure you understand, I wasn't thinking that you would. I actually put this challenge out, and I wasn't sure that either team would be able to make Friday's deadline. I was hoping you would, but I think you're both going to make it, which is awesome. So you should all be proud of what you've done. It's actually quite a challenging thing, and I know none of you have probably ever done anything like this before. I know I haven't either. It's easy to look at it and go, well, if I were to do it, I'd probably do it this way. But when you actually get into the nuts and bolts of writing code and then debugging, it gets pretty nasty. I didn't want to leave you guys hanging and just say, hey, it's a great project, theoretically it's going to work, go get them, without actually doing this myself. So I'm secretly have been Team Delta, and I've been writing code to do this stuff. I want to take you through some of the stuff I've done and share some things I've learned, and you might find some of this stuff useful in your own code. I'm not going to give away a lot of my code because I want to see what you guys come up with. And there's also value in us having code that works differently. Actually, it's quite beneficial. Ideally, coming out of this, when we're done with area detection, I want to have more than one algorithm that works well. So mine might work well for certain situations, yours might work well for others, and your teams might work well for other areas too. What we're going to use that for, say we have one algorithm that works really well on pages with a white background, just like this, super simple, and another one works really well on something else. What we're going to do when people submit a photo that they want to have decoded is we're actually going to launch multiple algorithms simultaneously, and each of those algorithms is going to detect areas. And then we're going to have another algorithm worker that we write that basically says, okay, I'm going to look at the results of the 2 or 3 or the 10 workers that detected areas, and I'm going to throw out the duplicates that they all found. And if one worker found an area that another one didn't, it's going to add it in. So it's going to combine all the results, throw out duplicates. So that's why it's okay if we don't all write the same way. It's actually much better. So with the challenge, what I'm going to modify the bonus challenge that I said last week. It's still, there's one team is going to win in terms of getting it done first. I assume that's just the way things work in life. But if both teams take different approaches, you guys have been using a canny image, you guys have been using grayscale part of the time.
Yeah.
So if you got
Most of the time.
So if you get a working solution by Friday with grayscale instead of canny, I'll still leave a bonus for you guys. If you don't take first place, if you win, and they don't, like if you take first place with grayscale, you get the main bonus. You guys will get something different, but because you're using different methods to doing it. If you're both using the same method, then probably not. So keep that in mind. That's the fact that you're doing it different ways is actually beneficial to us in the long run. All right, so you probably already found out this already, like your first day of coding, you got a lot of progress done, and then it's like the law of diminishing returns kicks in. So I sat down, I think Thursday I was sitting at home, I'm like, okay, well, I thought about what I told you guys about how to do it. I'm like, yeah, okay. And then I was trying to think through like, okay, yeah, it'll work. my mind kept jumping to the more complex examples, like, well, how am I going to handle columns, and trying to solve all the problems before I actually got there. And I'm like, well, fuck that. I always tell people, don't try to build a perfect system. You come out with what's called a minimum viable product. The first thing that actually works, it looks shitty, it doesn't do everything you want, but you get it out the door right away, and then you start improving it. That's the idea of a minimum viable product. A lot of people actually, whether they start companies or they start projects, whatever, they make a huge fatal mistake. Everybody does this. Everybody wants to have the best website, the best code, they want to make it their best so that they'll work on it forever, and they'll get it out too late. So if you do that in the real world, sometimes you lose out. Somebody else comes out with a solution or a product before you do, so it's better to get something out there early and then improve on it. This is the first version. I sat and thought about how I do it for about an hour, then I sat down and like 20 or 30 minutes of code, and I'm like, I got it. It started to detect the left-hand side, which is what I wanted to do. And then I just started to make some changes, adjust some tolerances so it would actually work its way all across the page until it got all the lines. And that was super quick. Like within an hour I had that, and I'm like, yeah, that's awesome. The rest is going to be easy, right? The rest started to take a lot longer. So you guys have seen this one. He started to work on that. That's where I was like, okay, I need to split columns now. And I threw it at Dilbert, and I'm like, okay, well, this works. Couple problems here I noticed from this. This area right here wasn't being caught because my algorithm only worked and it detected the first area, and then when I hit too much white space, it just stopped processing that line. That's not valid. So I was like, I gotta change that. So I made some changes to account for that. I also noticed here that because of the hanging Y and J and all that stuff, it was grouping all these sentences together. This is what I said was gonna happen with your code, and I think you both have run into that already. So I'm like, okay, well, I need to chop things in columns, because I got columns in Dilbert and I got columns in that other text, and I got to fix the rows. So first thing I did was I worked on the columns. So I got that working with just checking for enough white space. All the areas that were found initially were the whole line. Has anybody done columns yet?
We have working prototype for columns.
Working prototype. Do you guys?
I'm kind of almost there.
Early prototype. So here's the way I did it. I just scanned through for each area that I found. I scanned. Don't treat this as a one-pass process. I would say you're probably going to have multiple passes through the data, that once at least through the image, and then one or more times through the areas that have been generated, referencing the image then in each pass. So after the initial lines were captured, they were a whole line. I've got some code that just loops through each area that was found. I scan the image and those pixels, and the coordinates of that area, and I say if I've reached enough contiguous white space, that's where a column break should be. And I just actually, these blue areas were the original areas that extended all the way across the line. I shortened them up, because if you're gonna break something in two, you gotta get rid of the original or modify the original. I did that, and then these are new areas that were added to finish out the line. So don't limit your code to just one column. Realize there could be n columns. There could be 2 columns, 3 columns, 4 columns. You don't know how many, so you want to do that. So that's one way you can do columns. I started to modify the code. I haven't gone further than this. This is a big area that was being detected by a solid blob, and I started to implement the code where it's like you start from the top of the area, work your way down. Now, you guys have told about this. Have you guys overheard, or have I told you how to split rows? Do you need to split rows? Or is your algorithm working differently where you don't need to split them?
We would need to split them, yeah.
So one way that I would do, I think I told you guys about this, and this is what I plan on doing, is from the top of the area that you find, all the areas that you have, start scanning. Horizontally, you calculate the number of total pixels that you're traversing, left to right, and then you calculate the number of white or black pixels, colored pixels that you run into, and I use that ratio as sort of the density. If you found 10 out of 1,000, it's a 1% density, right? That's the density of that line. As you continue down, you increment like a max density variable. So if the density of any given line is greater than what you have for max density, increase max density. Okay, so you're always tracking the maximum density of the line. And then when you hit a line where the density is less than, say, 20%, 30% of max density, that's probably where a row break should take place. Because when you're passing through text, you got a lot of really, let's go back to one where we can actually see it. Go back to this one. When you're in the middle of this text, you're hitting a lot of points because you're right in the middle of all the characters, so it's pretty dense. When you drop off towards the bottom where you got the hanging Y, you're only hitting a few pixels. So that's an indicator that you've dropped out of an interest area, which happens to be a line of characters or something else, and you're into a new row. And you'd have to continue that logic. Let's say if the algorithm found this whole thing as one single area, you'd start up here, find a line break, I'd reduce the area to just that line, I'd then repeat the process all the way down here. You'd have to create new areas for these rows though, and just continue down to the highest Y value of your original area. Does that make sense? Okay. Other thing I wanted to go over. One thing you might want to do, especially next week, we're going to modify what we're doing for this week, and I'll talk about that in a minute. But one of the things that I did, so you guys all have the ability to call different functions if you use that area function parameter through the website. I actually used a similar method, but all the different algorithms that I wrote, I didn't overwrite my code because I know that I can commit it to Subversion and change it and go back and look. I don't want to do that. Every time I got something working, this is my first code right there, and I can go back and I can run that right now still. And then when I got that working, I cloned that entire function and just renamed the function. And I started working on that. So I can call my program right now with about five different steps. So I can see here's exactly what I did, the changes at each step, which is really useful. The difficult thing if you just rely on Subversion is you're gonna have to check out an old version. You're gonna have to test it again. Just leave all that code, I would say, in your file and just call it differently. Does that make sense? Everybody understand how this works? Okay. I want to show you something that'll make it easier for processing some images. So I was doing some testing. This is actually in the image library under the hard examples. Is actually pretty easy. But one of the things I noticed right away is this is written on really old paper or whatever it is. It's got a lot of lines increases, and I was like, oh shit, this is going to cause problems with the line detection, and it did. This is what. Let's open up the original. Let's open up Canny. So all these lines right here, you see, these were folds in the paper, and they're all over the place, which is a fucking nightmare. I was like, okay, it's gonna be so hard to detect like row distinction, even the methodology for, we can see a line of text right here, we got another one right here, but the whole methodology of trying to split rows based on density is gonna get tougher when you have all these like folds and stuff in the middle. So I looked, and somebody had written a program that cleaned up an image that was supposed to be like OCR scan text. So they cleaned up the image a little bit, like simplified or removed the background. And let's see, text E. Okay, so this is the image contrasted, the original one. And this is the image with the background cleaned up. So I was like, and this is not a Canny image yet. And I was like, this is exactly what's necessary to clean up some of this old stuff, because it's a mess dealing with old stuff. So that, and then when you run Canny on that, test E Canny, I think it was test 2 Canny. Looks a little bit cleaner. Let me put these things side by side here. So you can see at least the top part here, got rid of all these lines, got rid of some of the lines between. it destroyed a little. Every time we try to simplify the image, it destroys information or removes some information. Down here, you can see the text, fairly well with the canny image. When you clean up the background and try to make it easier to process, you do lose background information, but you do lose parts of the text. I don't think that'll be important for what we're doing. Obviously, we wouldn't want to do that when we try to do things like glyph matching, because we lose so much of the original glyph that you don't recognize what this is anymore. But it works well for area detection because we're just looking see if we collide with pixels of a certain color. So that code you guys can actually use if you want to. I don't think it shouldn't affect any of the initial tests you do this week. Next week, it probably will. So it's pretty easy to change your stuff. I'll send you guys all an email about this. Each of your code, there's a prep script that runs. Your project files, you can add this. It's pretty easy to clean up that text before you do the canny image. So you probably want that for next week. I think that's it. So, what questions do you guys have? What problems are you guys running into?
So the biggest problem right now, I guess, that we're trying to do the density detection and then break the column on there, is that going through it, so kind of there's a lot, if you go line by line, there are a lot of places within the lines where there's enough, on just one line of pixels, where that line of pixels average density is high enough, but there's a gap between two letters that are really tall or something like this, and you get 10 pixels in between there. That's less than, so that it detects that also, but that's not I can work with that and either dump them out or.
Are you doing column or are you doing row?
So we're going row by row and looking
Trying to do
at
column detection.
density. Yeah, trying to do the column detection. And really what I decided to start to, I just started to do this before we came down to do the meeting but instead of just looking at that row and then taking that and counting it as a gap, I'm looking just straight below it too to see if there's more beneath it.
Yeah, you could.
Count that as a gap.
Yeah, you could do that. That's one way to do it. A simpler way, the density of the entire row is better for row splitting, because you're capturing the, what does a whole sentence look like? I wouldn't use that method for splitting on columns. I would just keep going along, this row, and I would say, okay, I've hit a white or a black pixel with a candy image, and now I've hit 3 or 4 in a row. That, whatever my I have a minimum value variable in my code. When I've hit X number of pixels in a row that are white or black or background color, I say I'm at a column. And I keep track of where, I know where I am right now, and I said I've hit 5 of them, so I know where that column started. So that's how I make the break. You don't need to worry about what else is in the, in that line. I would just basically make sure you have X number of trailing pixels that are light or white or black, whatever the background color is. And that's where I make the split. Then you have to count, if you make a split right here at the end of the S, it looks kind of weird and it's not really very good. If you start the next area right here, the next area doesn't really start until you hit your first text. So.
How did you determine how many in a row was?
I just, the method I used is not, it's not very robust, because I just have some hard-coded numbers in there. I'll show you. I mean, the problem is, when we are processing arbitrary photos, ultimately, that somebody's uploading, we don't know the scale at which we're getting them. This right now is fairly big text, but an image this size could be a picture of an entire, two pages worth of a Bible page or something, and the text could be quite small. So putting hard-coded number of pixels into things is not ideal, and it's going to break on a lot of images that we test down the road. But that's what you have to do when you start testing. What do I got here? I've got a bunch of them. Delta. So like I have a variable here where it's like the minimum number of, when I do row splits to detect multiple lines, I know that I shouldn't split it like when it's 2 pixels big, because there's not going to be a sentence that's only 2 pixels. I say that my minimum row height has to be 15. I've just arbitrarily chosen that. And it might only be 10 at the end of my testing. I can change that. I've got other things here too where I say minimum area width to split. This is for columns. Minimum column width, 12 pixels. Cutoff area, I'm using that for something. I just put them all into hard-coded variables. I think long run, I started to do this with my code and I decided to comment it out for the time being, is not actually use hard-coded values, but use values that are based on either these numbers or a max or minimum of some percentage of the image dimensions, image width or image height. And all that is a best guess. Because somebody could take a close-up shot of, just a little bit of this, and they could say that's my image. And the number of pixels between characters would be huge. Our algorithm might slice each character into its own column. There are some things that we can't control that we don't know. Or that we wouldn't know till a later point. If we did glyph detection before we did area detection, we'd be able to have an idea of like how big the characters are. Because we'd say, we found the letter A and it's this big, but we don't know that right now. So that's how I do column stuff, just look for a trailing number of X things. Anything else you guys want to ask about? Any problems?
Will you pull up Dilbert?
Yeah.
Quick. So, I think you had this in your paragraph. Yeah, so in your paragraph right there, it catches them all, but say we have, we're drawing lines where it's low density, and we have just a huge stack of them, right? Like, because there's G's that go like this or whatever, so it
Yeah.
has 2 pixels every time if there's just 1 G. So it catches all of those. Do we take like the bottom or the top line that it catches?
Are you talking about in a paragraph or in
Yeah.
Dilbert?
In the paragraph itself. So like if there's 1 G hanging off, it catches, the G has a circle at the bottom, it catches 2 points, 2 pixels every time. Do we take the bottom point or the top point of that G?
I think that that's up to you. The thing is, like with our areas, they don't need to exactly include things. Ultimately, the use of areas, how we're going to use them. Get this a little bit bigger. When you've got a sentence here, it's, let's say we're a little bit smaller than the line or a little bit bigger, it doesn't matter so much as when we do glyph detection, we detect S, for example, we're going to get a box, and that box could end up hanging down above, below wherever our area. We're going to take the center point of that and say, what area is that center point in? So your area, it can be a little bit smaller than the actual text or a little bit bigger. That's going to be important for us when we do curved text, because I suggest that what we do is we don't try to do complex polygons. I suggest we just do rectangles and approximate the extent of the curved text. And I think we can get away with that. And I can go into that. But do you guys have any other questions about this? I'm probably not going to be here tomorrow, so I want any questions you have, any help you'd like to get should be today. Feel confident you'll get something working?
Oh, yeah.
It's hard to determine if there's confidence or not sometimes, so.
Well, I'm just kind of trying to figure out in my head, like, because you said that you basically just like hard-coded the number of leading pixels or trailing pixels for doing the column detection. Like, that would still, are you at all checking for like lines above and below that too? Because I feel like that would still hit like spaces in between like tall letters. Like if you had like an L and an H
Yeah.
or something, and there just happens to be a bunch of low letters in between them.
Or like a slash where like the top of the slash, like I hit a lot of white pixels, my algorithm would probably fail on that. If there were enough pixels, if there were more than like say 5 or 10, it could fail on that. Actually, in one of the tests I did Dilbert. In the Dilbert one, it was cutting, it was making a column, it was pissing me off, and I was trying to figure out why I was doing that. But You don't see it here. I wasn't doing column cuts yet, but it made a column where the copyright symbol was because it was light enough the KNE image didn't detect it, or it detected it a little bit. So it made a column there, and I'm like, fuck. I'm trying to adjust all my variables to make it work on Dilbert and the column thing and the non-column thing. And as soon as I throw this at something else, it just horribly breaks. So I'm trying to do it in a way where it's going to generically work. We don't want our algorithms to only work with the 6 images or so that we're going to test against. Otherwise, it's not going to be a good use case. So I don't know. I mean, right now, everything I've done is just hard coding things to make it work, and then to understand also my code, because sometimes I do things I'm like, oh shit, what impacted? I just changed one thing, and I totally fucked up columns, because it's working on the image I'm looking at. Like I'm modifying, I'm making some changes. I'm like, Dilbert's looking better, and then I go back to that other one that has columns, and it's totally fucked up, and I'm like, oh my god, what did I change? Because I have to go back and revert that. So that's one of the reasons why I've at least cloned my function codes so I can know what worked, keep what worked, and go back to it if I need. What was I going to show you?
So we can write like 5 different algorithms, one for like, I wouldn't say Dilbert specifically for images, then one for columns, and then one for just plain text.
Yeah, and that's what I do. Actually, in 2, don't do it in one pass. So here I've got some code where I actually keep executing a main function that I have that scans everything multiple times until I know I've finished scanning the image all the way to the right-hand side. Then I break it into columns. Then I'm going to split it into rows, but then I'm going to break it into columns again, because the first column code isn't going to work when the columns only appear somewhere in the middle of the image, which is the case on one of the, I was like, oh, I need it to work for a certain case, and I'll show you what that is. It actually, same thing, this will work with Dilbert too, so when it cuts this through in lines right here, like right now column detection breaks fail on this because my code, it detects that there's shit up here, so it won't break this into columns. So if I do row splits first and then column, it's gonna, each of these things will have multiple rows, hopefully where the text is located, with column splits just right there. So ideally, so I would write functions to just do specific things, column splits, row splits, general scanning, use them over again, whether it's for the recursion or just, iteration or something like that, to make use of multiple things. I was gonna show you that. Image library. This is the one that my code will fail on. First, the thing it detects, this is all one huge area, and I was disappointed at that, but then the row splits will cut each one individually. The initial column code wouldn't do anything because there's not a column here to split from the top to the bottom because there's solid stuff there. But if I split it by rows first and then by columns, I will end up with that center piece being separate. It'll actually be sliced in 3, but that's okay. So you can do things multiple times. It's not a one pass type thing. And just for anything that we do, I know it's like in class, your professors have said shit like optimize your code and ON squared is terrible, it's not good. I don't give a shit about your code performance, it's gotta work first. If it works, then we can improve the performance, but there's no point in having a well-performing algorithm that doesn't work. So let's get it to work first. I don't care if performance is terrible. This stuff is 2,000 years old, so if it takes an hour to decode an image, it's okay, So don't worry about performance yet. Is there anything else you guys have questions on or would like help with this stuff? Because I'm not gonna be here tomorrow. Wednesday I'm here a partial day. Thursday I'm here a partial day, so this is like my last day before Friday.
You can reach out an email like that.
Yeah, but it's always easier. Like if you got a question now, it's easier for me to explain it in person. I'll be in Thursday morning for a little bit and probably tomorrow afternoon for just a little bit. Nothing else? All right. I'll tell you a little bit what we're going to do after we get this stuff working. We're going to move on to the curved text portion. I'm assuming that we'll all get our code working by Friday. And then I think what we're going to do next week, this isn't even a really good example of it. There's some other examples, I'll have to upload them. We'll look at, right now, our code has just been assuming fairly straight lines and cutting through them. We're going to adjust our code so it can work with curved text. Text either curves up or down, and you have to take into account that each row could do something slightly different. If you write a handwritten letter, if you do it, your grandmother does, or somebody else does, you know that one row is pretty straight, or maybe it's a little bit off. Then every row you do, you're making adjustments. We need to take that into consideration, and there'll be some things we can do. But this is an example. Is anybody? You guys are all using rectangles or using polygons when you return areas? What are you guys doing right now?
Well, they're polygons, but
With 4 points,
Yeah.
right? So technically the software can deal with complex polygons. So we could, modify it, and we could, do staircase, stair-step polygon shapes. I say we don't do that because although we can do it, it's going to be a fucking nightmare in later stages when you do things like calculate how big is that thing, how close is something. It gets very complex. So I say what we do is we always use rectangles, and maybe like the rectangle for the second line actually is like right here. See how it's chopping into this top line? I say that's okay. This one would be, chopping into the top of that one too. But we'll take into consideration, we'll use the centroid of the area, which is essentially the midpoint, in some of the calculations to try to get around some of the alterations. Does that make sense?
What if we did like an image rotate, and then we do the boxes, and then we switch it back?
So we could. The problem is that it assumes that text is, we rotated 3%, we straighten everything out. That's an ideal case, and it's not in reality, something's straight and then the next line's up. So we could do a warp. The problem is we need to know the coordinates of the warp that are happening because we have to unwarp our coordinates for our array afterwards. I thought about that and I'm like, well, if we did anything, it would have to be right after the user submits the image, they'd have to preview it essentially. Like we've cleaned up the image or tried to, remove distortion. But in reality, we can't do that. Plus, we have to account for some things that shouldn't be, have distortion removed. For example, like in Mayan hieroglyphs, it's very intentional that they write around a circle, and we wouldn't want to try to open that up. We want to detect kind of what they're doing. That's a later stage. That's probably an internship next summer to do something advanced like that, text around a circle. But we'll do that next week. I think that's going to be our focus next week, extending this for curved stuff. I think our algorithms will work on hieroglyphics at this point. In two different cases. There's a third case that will be our final area detection project that we work on. I'm probably limited to a week as well. So that puts us at mid-June being done with area detection. But with hieroglyphs, our stuff should work. Let me see. What we got? Area detection, easy, simple, domain stock images. That's not a good one. Should work with images like this. That looks super complex, but again, we reduce it to grayscale. We use Canny images. Most of our algorithms work by, we assume that everything's in a horizontal row with text. I think one of the things that we're going to do at the website level, when somebody wants an image translated, we're going to ask them for some helper information, like is this stuff horizontally aligned or vertically aligned in columns. If they say it's vertical, then I think what we're going to do is before our algorithms process it, is we're going to turn the whole image 90 degrees. We're going to scan it like horizontal rows using our current algorithms, and then we're just going to convert all the points in our arrays to account for the rotation. That way we don't need to modify our algorithms, really, to adjust for vertical scanning. Because right now, we'd want our line of text to actually go down in columns rather than horizontal stuff. So, all right. Any questions? All right, so If we use two different methods for getting this thing done and both teams get it done, then both teams will get something. Make sense? But you gotta get it to work. You gotta pass the easy tests. Okay. All right, good luck, guys.